Hello grade 8 learners! We are now on the second week of our mathematics lesson, which is still all about mathematical system. Last time we discussed about undefined and defined terms. So today we are going to discuss about actions and postulates and theorems. Okay, let's start. Actions and postulates are statements which is accepted as true without proof. So here are the examples. The sun set in the west. The Philippines is found in Asia. There are 7 days in a week. These are observed facts that are already accepted as true even without proof. These are examples of axioms. Furthermore, postulates are assumptions specific to geometry, while axioms are generally statements used throughout mathematics. Postulates or axioms are statements that may be used to justify the statements in a proof. Now in geometry, let's talk about line postulate. So the line postulate says that there is exactly one line through any 2 points. So for example, we have point A and point B. So we are going to draw a line, and that is exactly one line. And let's name the line as line D. So this postulate is true. Line D contains points A and B. Next is the plane postulate. So this states that there is exactly one plane that contains any 3 non-collinear points. So here is the figure. For example, we have points A, B, and C. These 3 points are non-collinear. So it lies inside plane D. So remember last time that we named a plane using 3 points, and that point should be non-collinear. So through points A, B, and C, there is exactly one plane, which is plane D. Next postulate is a line connecting points in a plane also lies within the plane. So for example, we have points A and B, which lies within the plane C. So we are going to connect these 2 points using a line. So therefore, this line also lies within the plane. So if we have 2 points that lies inside the plane, if we are going to draw a line connecting that 2 points, the line also lies within the plane. So line AB lies in the plane C. So next, this postulate states that the intersection of any 2 distinct lines will be a single point. So for example, we have line AC or line CA, and then we have line BD or line DB. These 2 distinct lines intersect. So they intersect at a single point, which is point E. Next, the intersection of 2 planes is a line. So here's the figure. We have plane D and plane C, and this plane intersect. So they create a line, or they intersect, and they formed a line, which is the line AB. So when 2 planes intersect, they create a line. So plane C and D intersect at line AB. Now let's proceed to the properties of equality. First is the reflexive property of equality. When we say reflexive, a real number is always equal to itself. So to represent, we have A is equal to A. So for example, we have 12 is equal to 12. Next is the symmetric property of equality. When we say symmetric, quantities that are equal can be read forward or backward. So if A is equal to B, then B is equal to A. For example, if 3.5 is equal to 3 and 1/2, then 3 and 1/2 is equal to 3.5. Next is the transitive property of equality. So in transitive, if two numbers are equal to the same number, then the two numbers are equal to each other. So if A is equal to B and B is equal to C, then A is equal to C. Let's have an example. If 2A is equal to 10 and 10 is equal to 4B, then 2A is equal to 4B. Now the next property of equality is substitution property of equality. So if A is equal to B, then A can be substituted to B in any expression. For example, if x is equal to 5 and x plus y is equal to z, then 5 plus y is equal to z. Next, we have the addition property of equality and the multiplication property of equality. So in addition, if A is equal to B, then A plus C is equal to B plus C. While in multiplication, if A is equal to B, then A multiplied by C is equal to B multiplied by C. The next mathematical system is theorems. So a theorem is a statement that can be proven. Once a theorem is proven, it can also be used as a reason in proving other statements. So here are the definitions and theorems on triangles. So the sum of the measures of the interior angles of a triangle is 180 degrees. So for example, we have here triangle ABC. So the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Next, definition of equilateral triangle. An equilateral triangle has three congruent sides. So let's take this figure. For example, we have triangle ACB. When we say equilateral triangle, all the sides of triangle are congruent. So the sides AC, BC, and BA are all congruent. Next, we have definition of isosceles triangle. A triangle with two congruent sides is called isosceles. So I have here a figure. We have triangle ABC. As you can see, the two sides are congruent. Only two of the sides of a triangle is congruent. We have the side BA and AC. Next, isosceles triangle theorem. Base angles of isosceles triangles are congruent. So a while ago, we said that isosceles triangle has two congruent sides. So in any isosceles triangle, the angles opposite the congruent sides are also congruent. So in this figure, we have sides DE and EF. So side DE has a opposite angle, which is angle F, while side EF has an opposite angle, which is angle D. So this theorem states that base angles of isosceles triangle are congruent. Since their sides are congruent, therefore the opposite angles are also congruent. Exterior angle of a triangle. An exterior angle of a triangle is an angle that forms a linear pair with an interior angle of a triangle when a side of the triangle is extended. So let's take this figure. We have interior angles which are angle 1, angle 2, and angle 3. So this triangle is extended and it forms an exterior angle which is angle 4. So angle 4 as an exterior angle, it forms a linear pair with the interior angle, angle 3. Next is exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measure of the two remote interior angles of the triangle. So let's take this figure. A remote interior angles are those that don't share a vertex or corner of a triangle with the exterior angle. So in our example, angle 4 is an exterior angle and angle 1 and angle 2 are the remote interior angles of angle 4. So when we get the sum of the measure of angle 1 and angle 2, we will get the measure of angle 4. Definition of congruent triangles. Two triangles are congruent if and only if their vertices can be paired so that corresponding sides are congruent and corresponding angles are congruent. Included angle. Included angle is the angle formed by two distinct sides of a triangle. So we have side B and side C. So the included angle is angle A. So example, we have here angle YES is the included angle of EY and ES. We have angle EYS is the included angle of YE and YS. And angle YSE is the included angle of SE and SY. Now let's have included side. Included side is the side common to two angles of a triangle. So for example, we have angle A and angle B. The side common to this angle, is side C. Therefore, side C is the included side. Let's have this example. Side AW is the included side of angle WAE and angle EWA. Next, side EW is the included side of angle WAE and angle AEW. And side AE is the included side of angle WAE and angle AEW. Now let's proceed to triangle congruence postulates. First is the side or the SSS postulate. So we have here figure, as you can see, we have two triangles. So if three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. Next is the SAS triangle congruence postulate or the side angle side postulate. So we have here another two triangle As you can see, two of its sides are congruent to the other triangle and an angle. So if two sides and the included angle of a triangle are congruent to the two sides and the included angle of another triangle, then the two triangles are congruent. And we have here ASA triangle congruence postulate, or the angle side angle postulate. So if two angles and the included side of a triangle are congruent to two angles and the included angle of another triangle, then the two triangles are congruent. And that's it for our lesson for this week. I hope that you learn a lot from this new way of learning. Thank you for watching, keep safe, and God bless.